Hello, this is Dr. Raz. In this video, I would like to show you how to calculate sample and distribution mean using Python. To be able to get started, first I logged into our Blackboard page. Under 2.3, you should be able to see the data file, CSV file for the coffee shop, three dots, download, original file, and then you should be able to see 10 distribution sample means Python file, three dots, download original file. Then you can start a new tab in your browser. Make sure that you are logged into your personal Gmail account. And here we can do search for Colab and then click on Google Colab and then open Colab and then upload, browse, and then go to downloads and then find the Python file. Can close the previous tab and then click on this files icon. Wait for it to connect to runtime. Upload. Upload the CSV file that we just downloaded. Okay. First, I would like to import some libraries. Four libraries I will be using. One, Pandas. It's great for working with data, like more like a Excel spreadsheet, which will be Pandas. It will be abbreviated as PD. And also I download here, import here NumPy library, which is abbreviated as MP. And it's great for numerical array and mathematical calculations. To do plots, as you can see, import pyplot from matplotlib. And then this is abbreviated as PLT. And then to make some of our charts easier to build and make it fancier, we also use Seaborn module, which is built on top of the matplotlib library, and that will be abbreviated as SNS. So next step, you can see that we create data frame variable, and here we use pandas library and read underscore CSV function and make sure that your CSV name is exactly identical to CSV name that is provided. Next, what I would like to do is extract the data, and I call it as a population underscore data. That's the variable, and that value, those values will come from data frame that we create from CSV file column labeled as daily sales. And then we determine number of samples and sample size. So number of samples is 1,000 samples. Let's say we can change this. And sample size, every time we take sample, let's say has 30 random elements picked from the population. Let's run this code. Now what we would like to do is generate sample means by using NumPy library and use the mean which take the average function. And then here we have NumPy library, and then we do random choice to choose those numbers randomly from population data that we just created from here, which is daily sales column. And then the size of sample will be sample size, which is 30. And then we want to replace, which is true, which means that if you pick a number from this population data, we want to be able to pick it again and again because we don't want to just remove it and won't be able to take it again. Okay, so we will just keep taking the same ones potentially randomly. And then here we will do for loop in range for number of samples, which we have 1,000 samples. We'll be keep doing the same calculation, same random selection of 30 samples and take the average of those. And again, here underscore means that we don't really care about the index number for this. It's just we care about the averages. Okay, and then we will plot our chart. This is going to be 10-inch width and 6-inch height. And you can see that we will use the SNS. As you remember, SNS is Seaborn library to create this visual. And here we'll use his plot to create histogram based on sample means that are created right here in our for loop. And this is KDE equals to true, meaning that we just create a smooth density curve. So this is a histogram, but on top of it, we also create a smooth density curve to eliminate some of those bumps on our histogram to better understand shape of the distribution. and we chose 30 bins. There are 30 different bins here, or like bars, and we use the color sky blue. We could choose different color if you wanted to. And then plot title, sample distribution of the mean right here. And to be able to combine this variable sample size, which is determined right here, 30, this is a variable. And if we want to integrate the variable with string like this, we used f in front of it. So we can combine them together, and we put the variable in squirrely brackets. And then X label sample mean, as you can see right here. And then Y label is frequency right here. And then the grid lines, we show the grid lines to make it easier to read. And then we made plot tight layout because we don't want these numbers to overlap with each other. And we show the plot. So you can see that the histogram looks like this. It looks almost like a normal distribution. Again, the more samples you have, the more normal distribution kind of shape you will expect to have. That's it for this video. Until next video, enjoy business analytics.